Alright, so here in this video, we're going to look at our first calculation question on empirical formula. Alright, so the question here is a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. What is the empirical formula of the compound? So we're given the relative atomic mass of carbon to be 12, the relative atomic mass of oxygen to be 16, and the relative atomic mass of hydrogen to be 1. Alright, so again, the question is a compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. What is the empirical formula of the compound? So it's very important to note that whenever you're solving a question on empirical formula, there are two things that you should do. Number one is to find the mole. Alright, is to find the mole. Then number two is to divide by the smallest mole. So after finding a mole, whatever you get as your mole, you will not divide by the smallest mole. And you should know that mole is equal to what? Reacting mass over molar mass. Mole is equal to reacting mass over molar mass, right? So in this question, your reacting mass for the carbon is what? The percentage of carbon in this compound. And the molar mass of carbon is the relative atomic mass of carbon, which is 12. Alright, so let's put our solution here. So the first thing that you would want to do is to write out the elements. So what are the elements in this compound? What are the elements? So the elements are carbon, alright, hydrogen, and what? And oxygen. Carbon, hydrogen, and oxygen. Alright, so the next thing is to look for the mole of each of these elements. So like I said, mole is equal to reacting mass over molar mass. So the reacting mass is the percentage of the elements in this compound, and the molar mass is their relative atomic masses. So the mole for carbon is 40, which is the reacting mass, over the relative atomic mass of carbon, which is 12. Then that of hydrogen ratio, that of hydrogen is what? Is the mass of hydrogen is 6.7%, right? So that's 6.7 over the relative atomic mass of hydrogen, which is 1. And the mole for oxygen is equal to reacting mass over molar mass. So the reacting mass is the percentage of oxygen in this compound. So that's 53.3 divided by the relative atomic mass of oxygen, which is 16. Alright, so 40 divided by 12, if you divide that with your calculator, 40 divided by 12 will give you 3.33. Alright, then 6.7 divided by 1 will give you 6.7. Then 53.3 divided by 16 will give you 3.33. Alright, so with this you have gotten the mole. Then the next thing that you do is to divide by the smallest mole. Alright, so what is the smallest mole out of these 3 moles? So the smallest number out of these 3 moles is what? Is 3.33. So I will divide, what I will do here is to divide by the smallest what? By the smallest mole, or the smallest number. Alright, so this will be 3.33 divided by 3.33 because that's the smallest. 6.7 divided by 3.33 because that's the smallest. 3.33 divided by 3.33 because that's the smallest. Alright, so 3.33 divided by 3.33 will give us 1. 6.7 divided by 3.33, if I press that in my calculator, 6.7 divided by 3.33 is equal to 2.012. So that's approximately 2. So 2, alright. 3.33 divided by 3.33 will give me 1. So the ratio of carbon to hydrogen to oxygen in this compound is 1:2 ratio what? Ratio 1. 1:2 ratio 1. That's the ratio of carbon to hydrogen to oxygen in this compound. So therefore, the empirical formula of this compound is CH2O. That tells us that this compound is having 1 carbon ratio 2 hydrogen ratio what? 1 oxygen. This is the formula which shows the simplest whole number ratio of each atom of the elements that are present in this compound. Alright, so this is your empirical formula for this compound. Alright, it's a very simple and a straightforward question. So the major thing that you should note whenever you are solving any question in empirical formula is that there are two things that you need to do. Number one is to find the mole of each of the elements. And you know that mole is equal to reacting mass over molar mass. So your reacting mass is the percentage of each of the elements. Then your molar mass is the relative atomic masses of the elements. Then after looking for the mole, you now divide by the smallest mole. Alright, so basically there are two things that you do again. One is to find the mole, and then number two is to divide by the smallest mole.